Good morning, everyone, and welcome to the Inspecting Curb Ramps webinar. My name is Mike Fitch with the Ohio LTAP Center here at ODOT, and we appreciate your participation. We apologize for the audio issue, but let's proceed now with Ron Eck. Good morning, Ron.
Good morning, Mike. Thank you, and welcome, everyone. Appreciate your patience. I also apologize for the technical glitch we've been having here, so let's just get started immediately. Wanted to point out my email is on the slide there. Feel free after the session if you have questions or concerns to reach out to me. I'm always glad to try to help. Here's our agenda. It's a packed agenda, so we'll move right into it. Just a couple disclaimers at the start. This session is prepared for a general audience based on PROWAG, and I realize a number of your agencies go above and beyond PROWAG, so be sure to follow the relevant criteria for your jurisdiction. And this session is not meant to provide examples or illustrations of every field configuration or even every ADA criteria. Engineers, contractors, inspectors are still responsible for understanding and complying with all the local, state, and federal equal access laws, including the Americans with Disabilities Act. I'll show you a lot of photos of where to measure and the orientation of the digital level. They're not meant to show how many measurements to take, since this varies from agency to agency. So again, be sure to follow. If your agency has a policy on how many measurements, by all means, be sure to follow that policy. If your agency doesn't have a policy, as it says here, I suggest for a 5-foot wide by 5-foot long ramp, measurements of the landing, running slope, and cross slope, and ramp cross slope. And if wider or longer, add another row of measurements for each additional 2 feet of width and or length. If a surface doesn't appear planar, take additional measurements where it appears to be warped and record the steepest measurement, the steepest slope measured. Why is inspection so important? Well, let's start with the second bullet, really. To me, it's to accommodate users. And we're talking mainly about the mobility impaired, individuals in wheelchairs, those who use canes or crutches or braces or walkers, those assistive devices, also to accommodate the visually impaired. That includes individuals who are blind, as well as individuals with low vision who are not legally blind, but their vision is poor, and so they rely on contrasts and colors and textures to be able to navigate. But also inspection is important because obviously it's the law, and we don't want to not comply with the law. We're talking about the Americans with Disabilities Act, and two standards or criteria apply here. One is the 2010 ADA Design Standards, also known as the Americans with Disabilities Act Accessibility Guidelines, ADAG, and that applies to buildings and sites. And then we have the Public Rights of Way Accessibility Guidelines, PROWAG, which applies to the public rights of way. So that's sidewalks, streets, curb ramps, traffic signals, on-street parking, street furniture, and those sorts of things. Obviously, there's a variety of users. Each has different mobility needs or requirements, and you see really just a small sample here of the various devices or aids that folks use to get around, to navigate. And a key point I want to make is notice that the users range from the very young to the very old, and we need to accommodate everyone within that age range. Let's start with a few definitions, some terminology, and in the terms that follow, and these are going to be in alphabetical order. When you see the word grade, that refers to the finished grade, not the string line, the forms, or the wet concrete. And remember, there is no construction tolerance. We'll talk about that. First term is blended transition. This is a raised pedestrian street crossing, also called a depressed corner, connection between the pedestrian access route and the street, and the maximum grade is 5% or less. And a key thing with the blended transition is notice the curb is missing around the entire corner here. So we need the detectable warning surfaces. Cross slope, that's the grade that is perpendicular or at right angles to the direction of pedestrian travel. So as you see here, this digital level is measuring the cross slope of that sidewalk. Curb ramp. It's a ramp that cuts through or is built up to the curb to accomplish a change in elevation at the curb face so that someone with an assistive device can move between the sidewalk and the street. There's two types of curb ramps. We have the perpendicular ramp you see on the left and the parallel ramp on the right side. And we could have a combination of each of these, and we'll talk about that. Detectable warning surface, DWS. These are the truncated domes that are aligned in a particular pattern, and the surface has to contrast visually with the adjacent sidewalk or street or roadway. And they need to be placed anywhere the curb is missing at a street crossing. And they are, just as the name implies, they're a warning device. They're not used for wayfinding. They're a warning. And when a blind or low vision pedestrian detects this surface either with the cane tip or underfoot, it lets them know that they are moving from the sidewalk to the street. And so they need to listen for either traffic sounds or the sounds of a accessible pedestrian signal, the audible signal, to let them know when it's appropriate to cross the street. Flares. This is the gradual widening of the side of a curb ramp on one end, as you see here. And flares are needed when the ramp, the curb ramp, is located in a pedestrian circulation path, meaning pedestrians are likely to walk across the ramp. And the maximum slope of the flare, according to PROWAG, is 10%, measured parallel to the curb at the back of the curb. Grade breaks, this is where two surface planes with different grades meet. And PROWAG requires all grade breaks to be flush. Landing. This is the level area where movement and or turning maneuvers take place. And what I mean by that is, notice here we have the street. Let's say someone in a wheelchair is moving from the street to the sidewalk, and they continue on to the sidewalk that kind of exits the photo at the top. They're not turning, but they are moving across that surface. So that surface is a landing. But it's also possible, of course, that someone in a wheelchair may come up the ramp and turn left. In that case, they're using the landing as a turning space. So that area needs to be level. The pedestrian access route, or the PAR, I think I've already mentioned that, but this is the continuous, unobstructed path of travel that's provided for pedestrians with disabilities. So it complies with the PROWAG requirements, and it can be within or coincide with a pedestrian circulation path. So notice this image here. I've highlighted the PAR. That's the accessible portion of this pedestrian circulation path. This portion complies with the width, the cross slope, the surface, the grade, and other requirements. But the pedestrian circulation path is actually from the back of curb here to the storefronts. So in this case, we would say that the PAR is contained within the pedestrian circulation path. Should also mention obstructions. These are the physical features like poles, hydrants, signs, pedestrian push buttons, benches, bike racks, other street furniture that can reduce the effective width of the sidewalk. And this needs to be noted, and if possible, those obstructions, of course, shouldn't be there. They should be moved or relocated. We do need to, under PROWAG, maintain clear width around obstructions. And PROWAG, of course, requires a 4-foot minimum pedestrian access route. Running slope. That's the grade that's parallel to the direction of pedestrian travel. So here we have an individual, looks like maybe the inspector, kind of near the top of this ramp. And if he were to start moving forward down that ramp, we would say he is going down the running slope or going down grade, because it's parallel to the direction that he's traveling. So that's the terminology. One other thing I want to mention, we don't have time to cover it in this session, but where you're building ramps new or retrofitting ramps, make sure that the temporary traffic control is compliant at that construction or work area. And here, both PROWAG and Part 6 of the MUTCD apply. And the key questions to ask, in my opinion, are, is there an alternate pedestrian access route available to pedestrians? And are there cane detectable barricades? And notice the image here, I've put the red slash through it because this does not comply, doesn't meet either of those requirements. But again, we won't talk about it here, but that should be part of your thinking or your planning as you build or rebuild curb ramps at corners. Also, be sure you have the necessary tools. We'll talk about levels in a minute, but I would recommend an engineer's metal measuring tape that's capable of measuring in tenths or hundredths of a foot. And I'd record the linear dimensions to the nearest tenth of a foot. Unless your agency has a different policy, then of course follow your agency's policy. Make sure you have some sort of recording or writing tool depending on what you and your agency are using. This may be a tablet, a mobile device, might be old-fashioned paper and pencil and a clipboard, but make sure you have the appropriate tools that you need for documenting the inspection. And then I also recommend some sort of temporary pavement markers, because you may often have to make kind of temporary markings on the pavement. This could be chalk or lumber crayon or spray paint, something like that. Now, I mentioned digital levels. Interestingly, PROWAG does not make any mention of or requirement of the measuring devices. My advice is to use a 24-inch digital level. Number one, that approximates the wheelbase of a manual wheelchair, so that's one reason why it's appropriate. The other reason, I think, is that if your agency is ever involved in a ADA lawsuit or claim, if the Department of Justice or Federal Highway Administration would come to town to begin their investigation, they will be using 24-inch levels. So it might not be a bad idea to use the same type of device that investigators would be using. And then I also recommend having a 6-inch digital level available for measuring slopes on, portions of the curb ramp or the gutter pan that can't accommodate a 24-inch level. In terms of using the levels, be sure to calibrate the level according to the manufacturer's recommendations. At worst, calibrate it daily, but I would actually calibrate it throughout the day periodically, especially if you happen to drop it, it's sustained a substantial shock. I'd recalibrate it. And also, especially sometimes in the spring and the fall of the year, here in the East or Midwest, a cold front may move through or something, and so it may have been in the 60s in the morning temperature wise, and it's maybe in the 40s or 30s by the end of the day. Probably not a bad idea to calibrate the level again. And this last item wasn't on the original list when I put this class material together, but folks like you have suggested adding this last one, and I think it's a very good suggestion because I see this mistake made more often than I'd like to see. But that is, make sure your device is in percentage mode when you're recording your measurements or making your measurements. I think I said earlier, measure the forms, measure measure post-construction to ensure compliance. So now let's get into kind of the meat of the session. That is the basic requirements for curb ramps. And we'll look at the two types of curb ramps. We'll look at combination ramps, and then we'll look at blended transitions. We'll start with the perpendicular curb ramp. And here is this kind of a doctored photo that shows kind of the classic perpendicular curb ramp, if you will. The curb ramp is shown in this bluish tone. The darker portion down here, of course, is the detectable warning surface, the truncated domes. Notice there needs to be a flush transition, no more than a 1/4 inch vertical elevation difference between the gutter pan here and the curb. At the top of the ramp, we have a level landing. And notice this area up here is the PAR portion of this pedestrian path. This is the part that complies with the PROWAG PAR requirements. But notice the pedestrian circulation path is from the back of curb to the back of sidewalk. So the PAR is contained within the pedestrian circulation path. But notice the ramp is in the pedestrian circulation path, so it needs to have flared sides like you see here. 10% maximum slope measured at the back of curb parallel to the curb. What about the perpendicular curb ramp measurements? Remember earlier I said under PROWAG there's no allowance for construction tolerance. So that means we need to plan or design our ramps less than the maximum. So my suggestion is design the landing, running slope, and cross slope for 1.5%, so that when it's actually built, it won't exceed the maximum allowable value of 2.1%.
Hey, Ron.
Yes, Mike.
If you could we go back to the previous slide with the photo? We do have a question that came in.
Sure.
Okay, a question from Alice. She says, in this picture, does the PAR include in the outer part of the sidewalk past the flares?
Could you repeat that again, please?
The question was, in this picture, does the PAR include in the outer part of the sidewalk past the flares?
Yes, the PAR should, I believe, continues, at this same location at the back of the sidewalk for, let's say, the length of the block or two, if I'm understanding the question. It needs needs to continue to connect the rest of the the pedestrian grid, if you want to call it that.
Thank you. There's also a question from Angie. With the new PROWAG, does the ramp need to be directional to the path of travel crossing the street?
Yeah, great question, Angie, and thanks for pointing that out. Yeah, under the final rule, well, actually even under the draft, we should no longer be building single diagonal ramps, which this appears to be. So yeah, good catch there. Thank you for that. Yeah, we should be using directional, either perpendicular or parallel ramps or blended transitions. Those are the three types of, I would call them, allowable sidewalk to street transitions.
Thanks, Ron.
Thank you all. So in terms of measurements, of course, landing length and landing width match the curb ramp width and match the sidewalk width. For the ramp running slope, the maximum is 8.33%, but again, no allowance for construction tolerance. So many agencies design for 7.5% so that when they're built, the ramps won't exceed 8.3%. Of course, the flare slope needs to be 10% or less, needs to be 2 feet of detectable warning surface for the full width of the ramp, everywhere the curb is missing. Sidewalk cross slope 2.1% or less, and the counter gutter slope 5% or less. Ramp cross slope. For perpendicular ramps, the ramp cross slope is a function of the traffic control on the approach being crossed. So notice if the roadway is stop or yield controlled, the maximum ramp cross slope is 2.1%. If the roadway is signalized or has a pedestrian hybrid beacon or is uncontrolled, the ramp cross slope is 5% max. And for a mid-block crossing, the ramp cross slope can match the street grade. And note that where you're talking about roadways, say in West Virginia where I am, or southeastern Ohio, where we have significant topography, of course, we may have relatively steep roadway grades. And so an issue is, how do we transition from the level landing here to the roadway grade? And this is one technique. Actually, I picked this up at I think it was a U.S. Access Board webinar a couple years ago, which they show as a possible transition. But sometimes when I show that, some agencies will say to me, Ron, my agency wouldn't allow that. And that's fine. As I say here, not everybody agrees that that design is acceptable. I think we need some research on this topic, because the maximum rate of change of cross slope for ramps like this is not really clear. It's kind of a gray area of PROWAG. But my advice would be thoughtful about what's happening at these locations and document what you've done and why you did it. Let's get into the measurements then. And again, I'm just showing where to place the device. I'm not getting into how many measurements to take. And also, I've identified them just for organizational purposes as steps 1, 2, 3, and so forth. But obviously, you don't have to do it in that order. The key thing is make sure you measure all the elements. But my step 1 is to check the landing cross slope. So put the level on the landing perpendicular to the road. My step 2 is to check the landing running slope. So place the level on the landing parallel to the road. Then my step 3 is to check the ramp running slope. So place the level on the left, right, and center of the ramp perpendicular to the road, like you see here. Step 4 would be to check the ramp cross slope. So place the level on the front and back of the ramp parallel to the roadway. My step 5 would be to check the left flare slope. So put the level on the left flare at the back of the curb parallel to the roadway. And similarly in step 6, to check the right flare slope, put the level on the right flare at the back of curb parallel to the roadway. Step 7 would be to check the running slopes in the gutter area. The curb running slope and the ramp running slope should be the same. And so here's where to measure each element. For the curb running slope, notice this is where you may need to use the 6-inch level. And obviously you don't necessarily need six levels, but I'm showing here where you would make the measurements, and then you can average those to determine the average grade of the curb surface. And then for the counter slope, the same thing. You may not be able to use a 2-foot level, so that's where the 6-inch level may come in. I did want to mention wheelchairs and gutter pans, and I'll probably mention this several times throughout our session because it is important. Notice here, this is a staged situation, but notice that the wheelchair, the small front wheels of the wheelchair here have hit this lip at the base of the ramp. That lip is more than a 1/4 inch vertical. And you can see what happens. The wheelchair wheels stop suddenly and the wheelchair stops suddenly. And actually, if someone was in the chair, they might be pitched forward onto the sidewalk, which is not a good thing. So as the slide notes there, for able-bodied pedestrians, that 3/4 inch lip or whatever it might be, or 1-inch lip, really may just seem insignificant. We can just step over it. But for people using assistive devices, that can be a real barrier and a safety issue as well. So that was perpendicular ramps. Now let's look at the parallel curb ramp. And notice here the sidewalk ramps down and the landing is basically at street level, if you will. And here the parallel ramp is shown in the greenish tone, and the darker green here at the bottom behind the curb, that's the detectable warning surface. And notice our ramp grades here are 8.3%. And again, the flush transition between the sidewalk and the street. And notice in this case, excuse me, this is our PAR from back of curb to back of sidewalk. And actually, that's also the pedestrian circulation path. So in this case, the PAR and the pedestrian circulation path coincide. They are the same. I think in the other two examples where I pointed that out, the PAR was contained within the pedestrian circulation path, but here they coincide. Looking at the ramp measurements, again, I suggest the landing running slope be designed for 1.5% so that when it's built, it won't exceed 2.1%. Landing width and length, 4-foot minimum, and the ramp cross slope, 2.1 maximum. I suggest designing it for 1.5%. As before, a 2-foot length for the full width of the ramp of the detectable warning surface, the truncated domes. Sidewalk cross slope, 2.1% or less. Counter gutter slope, 5% or less. And it's not required in PROWAG. It's going to vary, I think, from site to site or location to location. But you may need a vertical curb behind the landing, and we'll look at some examples.
Hey, Ron.
Yeah.
Quick question, please. Question from Carl. Does a parallel ramp need to be placed at the back of curb, or could it be offset from the curb with a tree lawn?
Oh, good question. Let's see, I'm trying to visualize here. Typically, they are at back of curb, but I guess it could be, as long as you complied with all the requirements, I guess it could be offset. You'd want to put the detectable warning surface, though, at the back of curb. And I'd want to pay particular attention to drainage. That is one of the disadvantages of this type of curb ramp, is sometimes sediment and water and debris can accumulate in that landing area here because of its topographic position. But I would say you can probably do that. If you have a specific case you're working on or something, Carl, if you would want to send a photo or section of a plan or something, I'd be glad offline to look at it and give you my thoughts. But good question.
Thanks, Ron. We have a few other, also from Carl. Is there a limit to the running length of the ramp?
Well, PROWAG says that when you're chasing grade, which may occur oftentimes in hilly terrain, you don't need to go more than 15 feet. I mean, I guess you could have it longer, but PROWAG doesn't require that you go more than 15 feet. What I would say is look at it, I guess, maybe from a user standpoint and seeing what the grades are and so forth. And, if it's really steep and a long distance or something, you think about if you can do it, maybe putting in a level landing just as sort of a resting area for someone using a mobility device, an assistive device.
All right. Carl says thanks. We have a question from James. Should the landing width and length match the sidewalk width?
Generally, yes. I'll just say generally, yes. I guess there may be a few exceptions to that, but generally, yes, they should match.
Thanks, Ron. Question from Saeed. Should a max counter slope of 5% be considered for all types of curb ramps?
I would say if you can do it, yes, but there may be cases where you can't comply with that because of the street cross slope. And what PROWAG says, the final rule changed things just slightly in terms of how they worded things. They say the maximum change of grade or counter slope is 13.3%. And that comes from 8.3% grade here and then 5% cross slope or gradient for the crosswalk, if you will. So that's 13.3%. But they also say in the final rule that as an option, if you can do it, is to add a 2-foot level section here. And that makes that counter slope more user friendly by putting in a 2-foot level area. But that's an option. You can either use 13.3% maximum or put in a 2-foot level area, which if you can do it, I encourage that because it does make a more user-friendly path.
Thanks, Ron, and those are all of the questions for now.
Okay, thanks for those questions. The cross slope of a parallel curb ramp is 2.1% maximum. So where do we measure for parallel ramps? And before we get into the measurement, I mentioned that curb at the back of the landing. That's what we're talking about here. Again, this is not required in PROWAG, but here it's hard to tell, but it looks like the grass is elevated above the curb and the sidewalk here some considerable distance. So of course what might happen, depending on the soil and climate and such, you may have sediment eroding and washing onto the landing, or grass may extend onto the sidewalk area if you don't have this curb. So I think curb is a good idea from my perspective for, if nothing else, just for maintenance reasons, help minimize the maintenance that's needed on the landing. But anyway, my step one is to check the landing running slope. And to do that, place the level at the back and front of the landing parallel to the road. Step two would be to check the landing cross slope. So place the level perpendicular to the road on the left, right, and center of the landing. Step three would be to check the ramp left running slope. So place the level at the curb parallel with the roadway. Step four would be to check the ramp left cross slope. So place the level at the left and right side of the left ramp perpendicular to the road. Then step 5 would be to check the ramp right running slope. Place the level at the curb parallel with the roadway. And then step 6, check the ramp right cross slope. So place the level at the left and right side of the right ramp perpendicular to the road. And then step 7 would be similar to what it was for the perpendicular ramp. For the curb ramp running slope, take the average grade of the curb surface perpendicular to the flow line. And then likewise for the counter slope. And again, this is where you may need to use a 2-foot level. So those are the 2 types of curb ramps allowable in PROWAG, the perpendicular ramp and the parallel ramp. We can also have combination ramps like you see here. Notice how the sidewalk ramps down here and here to a landing, and then this landing is at the top of the curb ramp. And you see the detectable warning surface at the base of the ramp. That would be called a combination ramp. And I would just notice this, the sidewalk here, or this ramp, I guess I should note, is not in a pedestrian circulation path. Pedestrians will not be walking across this ramp. And so in that case, we can use vertical curb returns like you see here. Curb ramp measurements are similar to what we talked about before, just that there's more of them. Of course, designed for, in my opinion, design the running slope of the landing and the cross slope of the landing for 1.5%, so that when it's built, that cross slope won't exceed 2.1%. And likewise for the ramp, design it, I would say, for 7.5%, so that when it's built, it won't exceed 8.3%. And again, we need a 2-foot length of detectable warning surface for the full width of the ramp, and the counter gutter slope should be 5% or less. Ramp cross slope will be just as we talked about for perpendicular ramps. It's a function of the traffic control on the street being crossed. And so this slide simply repeats the slide I showed earlier when we were talking about cross slope of perpendicular ramps. So where do we make the measurements? My step 1 would be to check the landing running slope. And so put the level at the left, right, and center of the landing perpendicular to the road. And so notice here, this ramp is not in a pedestrian circulation path, so we can use the vertical curb returns. And also here we have the landing, and notice the use of the curb or little retaining wall there at the back of the landing, which in this case, I think that's a good idea. Step 2 is to check the landing cross slope. So put the level at the back and front of the landing parallel to the roadway. My step 3 would be to check the ramp left running slope. So put the level at the back and front of the sidewalk on the left ramp parallel to the road. Step 4, check the ramp left cross slope. So put the level at the left and right on the left ramp perpendicular to the road. Step 5 would be to check the right ramp running slope. So put the level on the right ramp parallel to the road. And then step 6 would be to check the ramp right cross slope. So put the level at the left and right on the right ramp perpendicular to the road. Then step 7, an added step here, is we need to check the ramp running slope. So put the level on the right, left, and in the middle of the center ramp perpendicular to the road. Step 8 would be to check the center ramp cross slope. So put the level at the front and back of the center ramp parallel to the roadway. And then now it's step 9 in a combination ramp, but now check the curb running slope just as we did earlier. And likewise, check the counter slope as we talked about earlier. And keep in mind, there could be combination ramps in both parallel and perpendicular directions. Just make sure you measure all the elements. And remember, any ramp exceeding 8.3% would not be compliant. So those were basically the 2+ types of curb ramps. The third type of sidewalk to street transition is the blended transition, which you see schematically on the right and then a photograph on the left. I'm sorry, schematic on the left, photograph on the right. I talked earlier about how the curb is missing around the entire corner, and so we need a detectable warning surface everywhere the curb is missing. And remember also, the maximum grade of a blended transition is 5%. And just one thing to note, it mentioned or a term introduced in the final rule is, notice here at the top of this blended transition is a level landing. And in the final rule, they call that a bypass, because the draft version of PROWAG was not necessarily clear that that was required. But if you think about it, not everybody, say, coming down this sidewalk from the upper left toward the lower right here, not everybody is crossing the street. Some individuals will be making a left turn to continue on this sidewalk, or vice versa. Someone on this sidewalk will make a right turn to go down this sidewalk. They're not interested in crossing the street. So there needs to be, at the top of every blended transition, needs to be that bypass or level landing for turning movements to be made. Here are the blended transition measurements, similar to what we've talked about before. Cross slope of a blended transition must be equal to or less than the cross slope of the crosswalk it serves. And where do we make the measurements? Step 1 is to check the ramp cross slope. So put the level perpendicular to the road in front of the domes. Step 2 would be to check the ramp running slope. So put the level parallel to the road. And I would just note here, notice this area here at the top of the transition would be called a pedestrian circulation area. Pedestrian travel can take place here. And so notice the whole area is kind of a brick surface. But notice here on this side of the blended transition, there's utility boxes or signal controller boxes. Not sure what they are, doesn't matter. But notice they prevent this area from being used as a pedestrian circulation path because there's these obstacles here. And so on this side of the blended transition, they have the vertical curb returns. And it looks like a flare over here. So you can do that. You just have to look at your specific situation in terms of, is it a pedestrian circulation path or not? Step 3 would be to measure the curb running slope, as we talked about before. And then also part of step 3 is to measure the counter slope. So those are the 3 types of sidewalk to street transitions. We have 2 types of curb ramps, plus the combination ramp, and also the blended transitions. So in the remaining time, what I'd like to do is talk about some other elements of curb ramps and also what I call some key curb ramp basics.
Hey, Ron?
Yes.
If you don't mind, we did have a few questions and comments. Question from Ken. What is the recommended offset from the edge of the DWS to the back of the curb? And he notes they like to use 2 to 3 inches where he works.
Yeah, I was going to say 2 inches. I mean, I think 3 inches would be okay too. Obviously, you have to look at each specific situation, but I would strive for 2 to 3 inches. I think that's a reasonable guideline.
Thanks, Ron. A couple things coming in. From Roger, can you still have curb continue around the radii and have the DWS around the radii?
Can I delay answering that? Because I think I'm going to talk about that here in a few minutes.
Okay.
And then if I don't answer the question, holler at me again. But I think we will talk about that.
Thanks, Ron. There was a comment from Shane. He said it might be worth noting that cross slope and running slope for ODOT is not 8.33 and 2.1. It is 7.69 and 1.56. So I reached out to our Office of Roadway Engineering a few minutes ago, and they wrote back. They said the 8.33 and 2.1 values are from PROWAG. ODOT requires 7.69 and 1.56 to build in a construction tolerance.
Okay, so that's consistent with what I've been talking about. Look, maybe different values than I mentioned, but yeah, that's good to know. Thanks.
Let me see. From Jared, what's the current guidance on diagonal versus straight intersection ramps? Are straight-oriented ramps preferred, or is it expected that PROAG will require them where possible in a future update?
Well, what's required are the types of ramps I've talked about here. The single diagonal ramps are not permitted in PROAG, and so we shouldn't be building any new single diagonal ramps. They may be acceptable in alterations if it's technically infeasible to use one of the other 3 types of sidewalk to street transitions.
Thanks, Ron. From Nicholas, in addition to the smart level and tape measure, would it be beneficial for an agency to test the curb ramps with a basic wheelchair to help identify lips and other issues that might not be noticed at first glance?
Absolutely. I didn't mention it, but I'm a proponent of doing exactly that. I encourage agencies to purchase a manual wheelchair. They're not that expensive. And maybe before you sign off on a project, have you or someone in your staff go through the project, navigate the project with the manual wheelchair, and even videotape it. And if you catch an area where one of the small front wheels of the wheelchair hangs up, or if it goes off the ground, creating instability for the wheelchair, to me those situations need to be corrected. And yeah, I really like that idea. And I don't know if you're doing that already. If not, I'd encourage you and others to think about just running through your jobs when they're completed, but maybe not yet signed off on. And that's a good practice. Also, it can help you minimize your ADA lawsuit exposure, because to me, it's evidence that you're making a good faith effort to try to comply with PROAG. So I like that idea.
Thanks, Ron. Question from Saeed. What are the maximum and minimum requirements for step 7 of parallel/perpendicular ramps?
Let me go back to that. Where was that? What was the question again? Maximum and minimum?
Question is, what are the maximum and minimum requirements for step 7 of parallel/perpendicular ramps?
Well, I think step 7 dealt with the curb running slope, which should match the curb ramp running slope. So it would be no more than 8.33%. And this counter slope should not exceed 5 50%. Those would be the maximums.
Thanks, Ron. Question from James. Should the DWS follow the curb or can it be perpendicular to pedestrian travel?
Can I delay answering that too? Because we will talk about that.
Okay. Question from Alexandria. Is there an amount of debris at the base of the curb ramp or blended transition when you believe it would become a hazard or make the ramp unusable?
Good question. I don't know that I can quantify it, but I would say if the debris or whatever is to the point where it's sort of covering the truncated domes such that they cannot be detected, that's maybe not a safety issue, but that would certainly be an accessibility issue. But also I've seen, and again, I don't know that we could quantify it, but I have seen some cases where there's maybe mud on the landing that could be a safety issue in terms of a slip and fall hazard. And I know I'm not giving a good answer, but that's because there are no specific criteria. And I'm not trying to be flippant, but a possible answer might be, you sort of know it when you see it, just based on the individual situation. I wish I could give you more specific criteria, but there really aren't. It's kind of subjective. But if it affects safety, as you noted, and if it is to the point where it may affect the detectability of the truncated domes, I would say then something needs to be done from a maintenance standpoint to clean the area up.
Thanks, Ron. Follow-up question from Saeed. Are there minimum slope requirements for all of these slopes?
I don't believe so. The factors you'd get into things like drainage, I think, and that sort of thing, but PROWAG does not specify minimums in general for these values.
Question from Joseph. Many times water accumulates at gutter. How is this eliminated?
Careful attention to elevations when you're in construction, or if you look at textbooks, I think say put ramps or put grates and inlets upstream of the ramps. I realize that's not always possible, but I would say careful attention to elevations when you're in the construction phase of the work.
All right. Thanks, Ron. Those are all the questions for now.
Okay. Thank you all for the questions. Did want to go over a few curb ramp basics. I think we need to design ramps for each location and not simply refer to a standard drawing, because most ramps don't look like these cookie cutter ramps that I might show. And to me, the engineering work should be done ahead of time, not by the field personnel trying to fit a ramp in at a particular corner. Also, be attentive to what I call skewed ramps, like you see here. Notice the ramp does not intersect the curb at right angles. And what happens is one wheel of the manual chair is off the ground. And when that happens, the stability of the chair is jeopardized and the chair can tip over or flip over. Again, no lips at the base of the ramp. And if you have a curb ramp on a shared use path, PROWAG requires that curb ramp to extend the full width of the shared use path, as you see here. Another situation is if a crossing is prohibited, it needs to be closed off to all pedestrians. So notice on the left here, probably due to traffic volumes and movements and such, this agency has decided to close this crosswalk. So there's no marked crosswalk here. The problem with just putting up a sign is that the blind pedestrian cannot get that information. And so, blind pedestrians, when they're walking, when they're undergoing training, they are taught when their cane detects a curb in front of them, that means they've reached a street. And what they need to do is listen for traffic sounds or signal sounds, and then when appropriate, cross the street. So a blind pedestrian can detect this curb, but there's nothing there to tell them they can't cross the street because they can't see this sign. And so what needs to be done is there needs to be a detectable end to the sidewalk. One way would be to put in a barricade or railing here, but I'm not a fan of that. As trucks turn, they may damage the railing, tear it out. A better way would be to put in 2 feet of detectable surface at the end of the sidewalk, between the sidewalk and the curb. So here you could put in 2 feet of grass. That would be a detectable surface. That would let the visually impaired know that the sidewalk ends, just like you see here. Now, just 2 feet. This looks like more than 2 feet, and it doesn't have to be bulbed out and be wider at the intersection. This is maybe not the best example, but you do have to have 2 feet of detectable surface at the end of the sidewalk there. Detectable warning surfaces, they do need to contrast visually. I would avoid using black since guide dogs and people with certain types of macular degeneration perceive that as a hole in the sidewalk and will walk around it. I like to say detectable warning surfaces are like parentheses. Use them in pairs. So you kind of close them and then open them. Or like here, this is the warning device. If someone's crossing from right to left, lets them know they're entering the street. Then when they encounter this one, it's not really a warning device, but it's letting them know they have completed their street crossing and they're out of the street. In this case, they're in a median. And then when they encounter this device, lets them know they're re-entering the street, and then there should be a device on this side. Directional ramps. I think a couple of the questions related to these. So notice here the ramp proceeds kind of into the photo. There's no sidewalk coming in from this side. And the rule is, what's the distance from the back of curb to the grade break? If that distance is less than 5 feet, then the detectable warning can be arranged in a linear strip at the grade break, like you see here. If that distance is more than 5 feet, then you need to use a radial installation, like you see here. The detectable warnings at the back of curb. And unfortunately, the photographs are kind of different scale. This is actually more than 5 feet here. Well, it looks like a short distance, but it's more than 5 feet, and so we need the radial installation. Truncated domes are required to be the full width of the ramp anywhere the sidewalk is flush with the roadway. So here's a good example. I'm embarrassed to say this is on the West Virginia University campus, where I worked for many years, but the curb is missing around this corner here. And this is a good example of how a little knowledge is a dangerous thing. I guess someone probably realized they need detectable warnings at the crosswalks, but they didn't understand how they work. And so they put them in more for directionality than functionality. But really what should be done here is there needs to be a detectable warning surface at the back of curb around the corner, around that entire corner there. This is not a correct installation. Another question maybe some of you have is, what about detectable warning surfaces at driveways? You have to look at each driveway separately, and actually the final rule did eliminate some of the gray area that existed here. This used to be a big gray area. The final rule says detectable warning surfaces are required where driveways are controlled with yield signs, stop signs, or traffic signals. So wherever a sidewalk crosses a driveway controlled by one of those devices, we need detectable warnings. For other driveways that don't have that traffic control, it's still a gray area. The things that I would look at are sight distance. Can drivers see pedestrians? Traffic volumes, I'd look at ADT, average daily traffic, and peak hour volumes. And I don't have specific volume quantities in mind, but just if the driveway starts looking like a street or acting like a street because of high traffic volumes, then I would put in detectable warning surfaces. I'd also look at curb radius. The larger the curb radius, of course, the higher the turning speed of vehicles. And if the curb radius is fairly large, I'd probably put in detectable warning surfaces where I might not for a small radius corner. But I would just say, whatever you do, document it and keep in mind that it is possible to overuse the detectable warning surfaces such that they can cause confusion for the visually impaired. And the detectable warnings also do cause, those surfaces do cause discomfort for individuals in wheelchairs with certain types of spinal cord injuries, and may also make it difficult for people, for example, with walkers to navigate that section of sidewalk. So that brings us to the end here. I did want to leave some time for questions, but our last topic is, this is Ron's top 10 list of curb ramp mistakes. And these are in no particular order, but these are things that I find are kind of done incorrectly unfortunately, on a frequent basis. And you're probably not surprised to see this one. I've harped on this already, but the ramp needs to be flush with the gutter pan. And notice this one on the upper left here. I mean, that looks like 1.5 inches. This is really, to me, an inaccessible curb ramp. Someone in a wheelchair, to get to that ramp, they really have to pop a wheelie with their wheelchair. And not everybody has the ability or the strength to do that. So that's why this really troubles me, because that lip is way too high, to the point where, as I said, I think that ramp is inaccessible. Kind of the reverse issue here, and you can't see the crosswalk markings are up the top here and bottom. This is in a crosswalk. The ramp is over here, and you can see the agency has repaved the street, but now they've left a big lip for someone trying to get into the street from the curb ramp. So that whole area needs to be flush. Obstructions are what are called protruding objects. And I realize in the East and Midwest, we have older infrastructure than, say, maybe the western part of the United States. And so we have above ground, underground utilities to deal with. And that can be a challenge when we're trying to comply with PROWAG. And here, I don't know the details of this, but it looks like this agency tried to make this corner accessible to the extent practicable to do so, given the above ground and underground utilities, although they do need a detectable warning surface here. This one on the right looks like a new installation, and so it sort of troubles me, because maybe they could have done it differently or done something differently. But notice we have the sidewalk here and the curb ramp and the detectable warning surface, but this, or these guy wires, or this one in particular, is what's called a protruding object. It extends into the pedestrian circulation path at a height above cane detection height, 27 inches. And so that means a visually impaired pedestrian will run into it before they detect it with their cane. And that's a safety issue. Someone can be harmed by running into not only a guy wire, but it could be a tree limb, it could be a sign, or whatever it might be. So we do need to pay attention to those protruding objects. And I'm not sure what happened here. My guess is, my hunch is, maybe the designer didn't make a site visit to see what the details of the site were. No level landing. Needs to be a level landing at the top of each ramp for turning. There's no way this static image here can make you appreciate the degree of difficulty involved in turning a wheelchair or a walker as you're trying to go up a grade. In fact, notice the individual's wearing gloves, not because it's cold weather, it's because they're trying to preserve the skin on the palm of their hands, making that maneuver of going up grade and turning. It's too bad we're not in person where we could go out in the field and demonstrate this, but keep in mind, every curb ramp where turning is done needs a level landing. Another issue I see is the detectable warning surface not flush with the walking surface, as you see here, kind of poor workmanship maybe, but notice they've created a lip that at spots is more than a 1/4 inch vertical, and that creates not only a barrier to movement, but also a potential tripping hazard for all pedestrians. So I talked about the importance of having a flush base at the ramp, but it's also important to have a flush detectable warning surface. And then also notice, which is a lead into our next slide, notice the detectable warning surface does not extend the full width of the ramp. And that's another common mistake I see. Notice here on the left, it's possible someone, a low vision pedestrian, could walk there without even stepping on the detectable warning surface, the truncated domes, and not realize they're entering the street. So the detectable warning surface here should be the full width of the ramp. A PROWAG allows 2 inches on each side, but that obviously that's way more than 2 inches. So this is not acceptable in my opinion. And here I'm not sure what happened. They made use of detectable warnings where the curb was missing here and at the crosswalk, but the curb is also missing in this section right here. And so there needs to be detectable warnings throughout this location here. Again, it's possible someone could, with a vision impairment, could walk into the street without realizing it. And again, to repeat, a blind or low vision pedestrian, they rely on tactile cues. One tactile cue is a curb. That lets them know they're entering the street. And when the curb is missing, that's why we need the truncated domes. They are a replacement cue for the curb for the visually impaired. And like I say, I'm not sure what happened here, but that gap is a safety issue because someone could enter the street without realizing it. We talked about the diagonal ramps, and I mentioned that they're not acceptable in new construction. And one reason is that notice that to get to that single diagonal ramp, this individual has to leave the protection of the crosswalk. He's out of the crosswalk, and think about it, his back is to traffic. Traffic is coming this way, so he can't even keep an eye on the traffic that's, potential conflict or danger to him. And so as to get into that ramp, he has to do this kind of maneuver. So that's one of the issues with the single diagonal ramps and why we should be using either perpendicular ramps, parallel ramps, or blended transitions. We didn't really talk about signals a whole lot today, but another mistake I see is no level area for the push button at the corners. It's important that someone in a wheelchair be on a level landing to access the push button. Notice this push button is on a slope here, on a grade. The problem is that to brake, B-R-A-K-E, to brake a manual wheelchair, the wheelchair user holds on to the wheels with their hands. And so here, to brake the chair, the individual in the wheelchair has their hands on the wheels. They don't have a free hand to activate the push button. So both of these push buttons should be adjacent to this level landing that you see toward the left of the slide here. No receiving ramp, no detectable warning surface either, but no receiving ramp over here. Remember, detectable warnings and ramps should be used in pairs. Someone can enter the street, and they need to be able to get back up onto the sidewalk. So that's a concern, and I see that, unfortunately, it's not uncommon. And then my last one here is misuse of return curbs. Remember, in return curbs should not be used where the ramp is in the pedestrian circulation path. So let's start in the upper left here. I'm not sure what happened here, but I guess someone read they needed a 4 or 5 foot ramp, and so that's what they installed. But now what it means is we have a vertical curb here that's a tripping hazard for able-bodied pedestrians, and it may be difficult to detect that. And so I'm not sure why they didn't just ramp down maybe the whole end of the sidewalk there and put the DWS across the entire width. Same thing here. Notice these ramps, the tops of these ramps are in a pedestrian circulation path, and so they should have flared sides. It's not an accessibility issue, it's a safety issue. And here's maybe a good example of that, a recent example. I just got this photo within the last few weeks. This city resurfaced this street that we see here a little bit of at the bottom, I guess last summer, and they recognize that when you resurface a street, you need to bring the curb ramps into compliance. So they did that, put perpendicular ramps here. Actually, I guess, a combination ramp to access the store here and to access this sidewalk. But the person who sent me this email, who had been to some of my training, said that earlier this year, the store manager contacted him and sent him some surveillance video of, as people are leaving the store, notice there's a column right outside the door. Apparently they're not perceiving this drop off here at the curb, and they're tripping and falling, and he wondered what could be done about it. Or actually, the reason this red rectangle is here with the X, he asked me, he said, what if we put a planter box here to just prevent people who are leaving the store from getting into this area? And I think that's a good solution, just prevent pedestrian passage in this area. But this is a good example of what can happen if we have the vertical curb returns in a pedestrian circulation area. And again, it's a safety issue. It's not an accessibility issue. So that concludes my presentation. Maybe we have a minute or two left for questions, Mike, but I want to thank everybody for participating. Thanks for your patience at the start. We did get everything in. You have my email there, and wish everybody a good rest of the day and hope to see you at future training. Mike, I'll turn it back to you for if we have any questions or for final closing comments.
Yes, thanks, Ron. As a reminder to our audience, the questions box is open. And since we did have a few audio issues at the start, we're glad to stay on a little extra to talk through questions. So, Ron, we have a question from Joshua. He says, is there a rule about a DWS in parking lots? I tend to see a DWS installed at a storefront leading to a parking lot.
Great question. I would say, as is often the case with ADA and PROWAG, and I'm not trying to evade your question, I would say it depends. Generally, I would say probably, and I think the final rule also states this, generally I would say I would not use detectable warnings, but there may be cases where that, say, the traffic aisle in the parking lot may kind of look or act like a street. So there might be cases where you want to install detectable warnings, but I would say generally not recommended for parking lots. Again, if you'd like to send me a photo or a plan section or something offline, I'd be glad to give you kind of specific feedback on that you might be facing.
Question from Roger. Where asphalt meets the gutter, is a 1/4 inch lip allowed?
Yes, no more than a 1/4 inch vertical. But yes, a 1/4 inch would be allowed.
Ron, I'm going to copy questions to you in the chat. I think the audience can hear you, but I'm not able to hear you.
Okay, I hope everybody can hear me. I guess Mike can't, but we have a question per PROWAG. if you have a sidewalk that ends on one side of the road at an intersection with no sidewalk or par on the other side, do you need to have a curb ramp / detectable warning on the side of the intersection that does not have a sidewalk? Great question. And again, I'm sorry I have to give the same answer. I'll say it depends. For example, it might depend on, is that corner that doesn't have a par or a sidewalk, is it in the plan somewhere, or maybe something is actually planned that within the foreseeable future there will be a subdivision on the other side of the street or a retail development that will have sidewalks. I would say in that case, you probably should go ahead and put the curb ramp and detectable warning on the other side of the street. If you're at maybe the edge of town and what's beyond that area is a wooded area or farm fields or something like that, and no development is planned, I would say probably you don't need to have a curb ramp on the other side of the intersection, but I would document that. In both cases, I would document the situation. Okay, we have a question from Dave. Do the ramps have to be as wide as the crosswalk? Can flares be located within the crosswalk be considered a hazard where the curbs start to transition? No, the ramps don't have to be as wide as the crosswalk. They need to be within the crosswalk. And those, yes, it is possible that I'm aware that sometimes trip and falls do occur due to the flares or that transition area. So you might want to think maybe about painting the vertical edge of that curb to maybe make it more visible is one thing that some agencies have done. Good question. Then from Caden, are receiving ramps required to be in line or can they be skewed? Now, desirably, they should be in line, Caden, but they can be skewed. In fact, on large radius corners, of course, for the ramp to intersect the curb at right angles, there will be a skewed situation. So they can be skewed. And then from Eric, on the last example with the combination ramps, would it have been better to remove the raised curbed island in the radius and install a radial DWS? Okay, let me try to go back to that. And I think you're referring to that one. And the question is, would it have been better to remove this island and install a radial? This is a gray area. There's no requirement that applies there. But personally, I like the directional ramps. But it would be okay. It wouldn't be a PROWAG violation. You could take this out and put the detectable warnings all the way around. The reason I'm not a big fan of that is it doesn't give a whole lot of guidance to the visually impaired. Whereas here with the directional ramps, they have a little better guidance to find their way, to navigate across the street. It lines up better with the sidewalk and ramps on the other side of the street. But that's I'm sharing my opinion with you. And let's see, from Shelby, I think these are the same questions. Yeah, I think Shelby had the same question. If I haven't answered that, just let me know. I guess we have no other questions. So again, I'll thank everybody. And Have a good rest of the day and hope to see you at future LTAP training.
Hey, Ron, can you hear me now?
I hear you now.
Well, I saw that you worked through all those questions, so thanks so much for doing that. And I really want to thank our audience for their patience and participation today. We will send out a follow-up email with a link to the presentation PDF. And there also will be a recording of this webinar. Hopefully the technology for the recording worked well today. So we'll have a follow-up email with the webinar recording also. So again, thanks, Ron, so much for presenting today's webinar. We really appreciate it.
Oh, thank you, and thank everybody for participating and for your great questions.
All right, everyone, have a great day. Thanks.